In the 20th century, right now, as we move into the second decade of the 20th century, there's a lot of angst. And there are two engines of that anxiety. One is the sense that we have too much. We have too many people, which leads to overcrowding, congestion, and pollution. And those people want a lot of stuff, which means we have rampant consumerism. They want to buy a lot of things, and that can create a lot of waste. And finally, there's angst about too much technology. Is technology going to take our jobs away and make us, as humans, irrelevant? At the same time, the other engine of our angst is a fear of too little. Do we have too few natural resources, too little land, too little energy to support all of our needs? Do we have too few good jobs that will sustain us and our lifestyles? And ironically, while we worry about too few good jobs, employers worry about too few skills. Do we have the skills we need to get the job done? So I work for Autodesk. We make software to design and make things. Buildings, infrastructure, manufactured products, and entertainment. So we automate the process of design and making. And some might say we're the cause, or at least one of the causes of this angst, because we've taken this kind of work and done this with it. And increasingly, we're automating the process of making things. So if you look at the popular press, you'll see stories like these. Robots are going to take our jobs. We are irrelevant as humans. And there's this depiction of a robot apocalypse. The robots and artificial intelligence are coming for us. This is kind of a dystopian view. It's a view that the locus of control of technology moves from us to these autonomous machines. We think that's a false view. We think the robots are coming, but they're coming for us. They're coming to help us. So ultimately, robots and tools like them are just tools. They're extensions of our ability. So throughout human history, we've shaped our tools, and they've shaped what we can make with them. So the stone hand axe is an extension of the human hand. And for years and years, thousands of years, we amplified our muscles with tools like this. Then with the digital revolution, we started amplifying our minds. So when we think about tools like robots and artificial intelligence, those tools will also amplify human abilities. And we don't believe that the locus of control will move to the tools. We actually believe it'll be a shared control. These tools will be more like partners. They'll let us do together more than we could do alone. So the question isn't really, will automation take our jobs? It's what can we do with automation? Where can we take automation? So let's look at the arc of technology over history. If you were a farmer or a farm worker at the turn of the last century, you'd be quite alarmed at this picture, because a huge percentage of our population worked in agriculture, and they used things like horses. Here you see very few workers and no horses. So jobs were displaced by technology in farming. But we ended up with a cornucopia of food. We ended up with great food, lots of it, probably too much of it, and high quality food. Similarly, we had weavers in that time period that were put out of work by technology. Yet, we ended up with a higher quality of life. These girls might have previously been able to afford one outfit, but because of automated weaving, they could afford many outfits. And we had a challenge because our workers weren't trained to deal with this. So we had to invent mass education. We had to invent education where we took all youngsters, put them through school in a standardized way, standardized classrooms, standardized curriculum, standardized testing. And what that did is it created workers ideally suited for the 20th century era of automation, of mass production. And of course, we change working conditions from this to something more like this. This is the arc, the arcs of history, agricultural, industrial, and digital revolutions. They always destroy jobs, but in the end, they always create more jobs. And those jobs typically are richer, provide more wealth, but require greater skills. These curves increase the wealth of society. It's what gives us a higher standard of living. So is it different this time? Well, I think the answer is yes and no. It's not different. No, it's not different in that technology will continue to provide a higher standard of living. It will, in the short run, displace jobs and require more skills. It may be different in that the skills are different. That our relationship with our tools will change from being very instrumental to being partners. So the tools throughout history have been instrumental. We have told them what to do, and they've shaped what we can make. And ultimately, they shape the kinds of things we can make. But as we go forward, tools will change. They'll move from tools of simply execution, doing what we tell them to do, to also tools of exploration, letting our minds explore more and more possibilities for design and making. So I have tools of execution and exploration. Let me give you an example. This is Brittany. She was an intern at Autodesk for several years. And like a lot of interns, she wanted to design and make a chair inspired by this chair. She didn't want to just replicate this chair. She wanted to be inspired by this chair. But she wanted to use a different kind of tool called generative design. And the idea is that she wouldn't just give form to the chair. She wouldn't make the shape of the chair in a design tool. She would express the loads and the constraints and the conditions. She would say, here's what I want out of a chair, not here's the chair I want. Subtle difference. So the computer then generated lots and lots of alternatives. Computation is basically free, so the computer could generate all kinds of ideas. As we heard earlier this morning, the greater the number of ideas, the more chances you have at innovation. So some of these ideas were good, some were bad, and she could decide for herself which ideas she wanted. So ultimately, this is the idea she selected. It's not a chair that you might design on your own. It's a chair designed by computer in partnership with Brittany, based on the constraints she had. And she designed and made this chair in about 2 weeks. So computation is expanding the universe of things of problems we can solve, things we can design, things we can make. What problems do we want to solve? Well, there's clearly a number of problems. And if we go back to that first engine of angst that I talked about, we have a clue. Right now, there are about 7 billion people on the planet. By 2050, we'll have 10 billion people. That's a huge number of people, 3 billion people joining the planet in the next 30 years. That's 1 billion people a year. And those people, many of them, are joining the middle class. So every day, 400,000 people join the middle class, mostly in emerging markets like China, India, Africa. So that's half the population of San Francisco. Every day, they become middle class. And when they do so, they want the things that we all enjoy. Good food, transportation, and consumer devices. 2/3 of us will live in cities in that same time period by 2050. Right now, about half of us live in cities. So that means we're going to have to produce 1,000 buildings a day. We will have to build around the world 1,000 buildings a day. That's a lot of construction. We'll have to produce the infrastructure to support that construction. And of course, infrastructure doesn't stay still. We have to repair and refurbish that infrastructure. So think about that. Over the course of the next 30 years, we'll have to build whole new cities. We'll have to build buildings, roads, transportation networks, communications networks, water systems, schools, hospitals, all the things that support human life. And we'll have to do that with less negative impact on the planet, on people, and on society. So that's a big design challenge. We have these huge demands, and these demands are inevitable. And we have these constraints, which is trying to do things with less negative impact. So let's look at an example of negative impact in the building industry. So construction, and this is a well-known figure, is about 30% inefficient, which means in any construction project, if you actually look at what is done, about 30% of the labor is wasted and 30% of the materials are wasted. So that's like, for any construction job, take 30% of the money you're going to put into it and just burn it up. So that's an example of negative impact. If you look at landfills, about 40% of the content of landfills is construction waste. And about 40% of the energy used around the world is for buildings. We over-engineer our buildings. We put too much concrete and too much rebar in them because we don't necessarily know how they'll perform. We do the same thing with consumer products. We take vehicles like this and put a lot of steel in them to make sure they're safe. We put big engines in them to overcome all that steel. The big engines make them heavier, so we have to have even bigger engines. So we've over-engineered our consumer products. And consumer products are interesting because in an era of mass production, which we really mastered in the 20th century, consumer products are actually very generic. There's one, and we make hundreds of thousands of units of it. And then we invented something called advertising in the middle of the 20th century to convince you that you needed the thing we made. So we think one of the design challenges we have is moving from making people want the things we make to actually making the things people want. So that's quite different. Here's another generatively designed. This is the motorcycle swing arm. It connects the engine to the frame of the motorcycle. You can see it's very, it looks very biological. It's because generative design algorithms do what nature does. They try lots of things and genetically come up with good solutions. Turns out that's how nature works. So we think, as designers, we're confronted with the inevitability of more. There will be more demand. We know that's going to happen. Those people that are creating that demand have been born already, and they're moving into the middle class. So that's inevitable. And there's the reality of less negative impact on society. We have to reduce the impact both on the natural resources we use, but also the negative impact on society and on labor. But that creates a design opportunity. It's one of our biggest challenges, but it gives us the opportunity to do things better. And this is what designers have always done. We've imagined a future, we've modeled that future, and in fact, we've tried to project forward a better future than we have today. So let me give you an example of designing better things. This is Under Armour, and they wanted to take a simple product, a running shoe, and they wanted to make that product strong, the sole of that product strong and light. And they did so by imagining what tree roots would do, what tree roots would be. So this is how they did it. They used generative design to model the tree roots. It'd be very difficult to model tree roots directly, but when you generate them using the computer, it's fairly straightforward. Then they used 3D printing to print the sole. So what they did is they created all these spaces inside the sole that made it lighter, but still maintained the strength they needed for the shoe. So that could only be done with 3D printing, because in 3D printing, complexity comes for free. We took some of those same generative design ideas I talked about and are applying them to the built environment. We have a research group in Toronto, Canada, and that group moved to a new building called Mars. It's an incubator connected with the University of Toronto. And we decided we'd apply the same principles that I talked about to make geometry to actually deal with floor layout. So typically, when someone moves into a new space, the space planners lay out the floors, and they have a vague idea of what people need, who needs to be next to who needs to be next to what resources. Often, they're driven by political constraints, so it's not necessarily an optimum solution for people. So what we decided to do is really try to optimize for a number of factors. We went and interviewed all the employees to understand the resources they needed to be close to, the people they needed to be close to, their preferences for privacy, their preferences for daylight, their preferences for collaboration, all of those things. We fed those into an algorithm, which then generated literally thousands and thousands of alternatives, and it evaluated those alternatives against the criteria we gave it. It's figuring out daylight now. So we were just, and then you can see some of the alternatives that were generated. So again, innovation happens when you generate lots and lots of ideas, and it turns out if you frame the ideas correctly, that's what computers are really, really good at. So designers move from being form givers to problem framers. This is an experiment. We are just now occupying this space in Toronto, so it remains to be seen how effective it is, but it's an example. Let's talk about making better things. This is a concept video from Airbus, from their cabin concepts group. So they're trying to envision what the flight experience will be like up to 30 years in advance. They have to plan, for airplanes you have to plan a long time ahead. And I don't know about you, but when I flew over here from the United States, my cabin experience was not like this. So we worked with Airbus to think about how could you begin to create that experience? Because clearly the materials and the methods used to create that airframe are different than what we do today. So we started with this red cabin partition here. That's the partition that separates the passengers from the crew, and you can see the white crew seats bolt onto that. That's a pretty critical piece of infrastructure inside the airplane. So we developed this using generative design algorithms and 3D printing. So this is actually a cabin partition. It doesn't look like something that a human designer would do, but it was done by a human designer in concert with a computer. In fact, the algorithm has something to do with a particular kind of mushroom. That's how the mushroom grows. What that resulted in was a crew partition that's the same strength as the original partition, but half the weight. So you look at all the Airbuses in the world and could replace the cabin partitions in those Airbuses with this cabin partition. It's the equivalent of taking 10,000 cars off the road. Aviation tends to be fairly energy intensive. So if you can imagine all the seat brackets holding up all the seats in all the airplanes using a similar thing, you can imagine the difference we could make just doing simple things like that. So that's an example of making better things. We're also experimenting with robots. Industrial robotics have been around for a long time, but typically they've been very rote. They're batch programmed, and they tend to do the same thing repetitively. They don't have much sense. Literally, they don't have any senses. So what we're trying to do is give them senses and have them interpret things the way humans might do so. So this is Ash. You can see some little eyes there, and Ash is welding. And when you weld, the welder actually interacts with the material. It's not just a process of doing the welding. You actually have to see how the welding works, and there's an interpretation loop, and Ash is able to do that. And you can see Ash was able to weld Brittany's chair. Similar to the wooden chair, but it's definitely got a different character. That's something that a human would have a very difficult time doing. A robot traditionally wouldn't have been able to do, but a robot with computer vision and this feedback loop could do it. So we're trying to give robots senses. Similar project, which now scales up, is an artist named Joris Laarman in the Netherlands, pretty close to here, is trying to build a 3D printed bridge, or more accurately a 3D welded bridge, that crosses a canal in the red light district of Amsterdam. So you can see the robot welding here. Again, it's watching the weld, so it's very difficult to get the metal to cool exactly right. There's a lot of science involved in this. You can see the test of the bridge going up. It lets you create fairly unusual shapes. This shows you how the designers are envisioning it. And again, using generative design, they can kind of create these very complex structures that would be impossible to make if they weren't welding it. Here you can see the bridge in context. Now, we've never made bridges like this before, so we're really trying to understand not just the making process, but the structure of the bridge. So in fact, we're creating what's called a digital twin. We're censoring the bridge so that we can do a number of things. One, we can understand the structural behavior, but also the city can see how the bridge is used. They can find out when the traffic patterns are there. They're starting to understand traffic patterns around that neighborhood. So that's an example of the bridge. That's what it looks like in the test. And there's the digital twin right there, showing the structure that our sensors are picking up. And that's what the test of the bridge looks like. The real bridge, of course, will span the canal. Now, how do we both design and build better things? This is another example from the Netherlands, a company called Van Wijnen. They do low-income housing. And in addition to the low-income housing like this, they also do net zero housing. They're very focused on energy efficiency. So they've got two goals that sometimes people would think are in conflict. Doing a net zero house, doing low-income housing. And they realized that, as I mentioned, construction is really inefficient. They're a business, so they're worried about their margins, which in construction are about 2%. They're saying there's got to be a better way. So they went and looked at how other industries work. How do aerospace companies work? How do automotive companies work? And they said, let's adopt some of the techniques and apply them to construction. So they built a system, a modular system of housing with all kinds of standard components. So it's a design language and a making language. They could then go prefabricate these components in a factory. And when you make things in a factory, you have better quality control. You're not subject to things like the weather. You have more reliability and less waste. So they could actually do all the things we've learned in manufacturing over the many, many years and try to optimize the creation of these components. So they made a bunch of components, and they could then assemble them based on the need. But they came to us and said, we want to do more. We want to optimize for a number of factors. So can we use that generative design technique that you talked about to optimize our housing? So they wanted to generate lots and lots of alternatives for a given plot of land. And they did it by doing what we did with the Mars space, providing a whole bunch of constraints, and then generating lots of alternatives. Now, what's interesting about these alternatives is in the very first design I showed you, the chair, those were mostly structural constraints. They gave it a bunch of other constraints, things like solar gain, cost, profit as a business, so they could optimize for all of those things. So they, again, ran lots and lots of variations and said, okay, what's the best one? So when we think about technology, historically, we've thought about technology as a way of optimizing what we've already done, what we've done manually or done in other ways. And clearly, that's been something that designers and makers have done for years and years and years. Optimizing for human comfort, optimizing for strength, and optimizing for density. But that's really, and that's kind of how we think about technology. Think about something like this. It's optimizing a process that we've already done before. But what we as designers and makers do is apply our imagination. So what if we could actually make anything? What if we could design anything? Because a lot of what these tools are doing is removing some of the constraints of what we had and letting us kind of unfetter our imaginations. So we can create better environments for people. We can create better furniture, and we can create better neighborhoods and housing. So we think that the fear of scarce jobs is misplaced. It's not really about scarce jobs. The world has incredible needs, and as designers and makers, we're in an ideal position to address those needs. The challenge is different. The challenge is scarce skills. Because as our relationship with technology changes, we need different skills. And that's what has happened throughout history. If you look at those arcs of history I showed, what we had to do was always develop new skills when a new technology came forward. So this is something we're starting to think about. This gives you a glimpse of how we're thinking of addressing this. This is one of our tools, and we have a designer named Darren, product designer. And the dots, the blue dots you see there, are things he has done with the product. The red dots are things he hasn't done, things that he might want to learn. In fact, there's an envelope of what a typical product designer knows. So the tool is, while he's working, it's diagnosing his skills and also trying to give him new skills, give him the opportunity to learn new things. So the tools we have going forward are really going to become design partners, not instrumental tools that we tell what to do. And like a partner, they're going to learn from us, they're going to teach us, and they're going to challenge us. So we're going to move from these instrumental tools we tell what to do to a true design partner. We don't believe in the robot apocalypse. We don't believe technology is coming for us. We believe that we will actually be able to do more together with technology than we can without it. So we're moving into a whole different world. This is actually a project where we gave the team that assignment. We said, create a structure that robots and humans could not do together, and they did. So we think the big design challenge is to confront the inevitability of more. We know that's going to happen. We know that demand is there. The reality of less negative impact, and for designers, we have the opportunity to do better, to create better designs and better work, and we can do that in partnership with technology. So we can make a better world, make better things, and we believe that we all can make anything. Thanks.